Now, the two standard deviation method is only used when we're trying to estimate a 95% confidence interval, only for this. You'll never, ever be allowed to use this to find like a 99% interval or a 98% interval or anything like that. It only works for a 95% confidence interval. So to do this, I'm going to go ahead and go through an example. It says 1,034 random U.S. adults are surveyed. They're asked, does the new healthcare law affect the respondent or their family? And 69% of the sample said that it had no effect. We want to find a 95% confidence interval estimate of the proportion of all Americans who feel that the law has no effect on them. Okay, so just noticing here, we have a p-hat of 0.69. That was our sample statistic. And this 1,034 is our sample size, so that's n. We are trying to build a confidence interval. So remember, the statistic always goes in the middle. So right off the bat, I can start off my confidence interval drawing here by putting the 0.69 right in the middle. We want to then find that margin of error so that we can find the lower end and the upper end of our confidence interval. Now, with this 2SD method, this margin of error is found by taking 2 times that standard error estimate. And the standard error estimate is going to be found if we're using a categorical sample like we have here with this formula, square root of p-hat 1 minus p-hat over n. Now notice that is very close to the true standard error of the distribution of sample statistics, which was pi 1 minus pi over n. But remember, we're trying to estimate the value of pi. We do not know it. All we really have is p-hat. So we are using an estimate of that standard error here with the square root of p-hat 1 minus p-hat over n. Now to find this margin of error, we're going to use that formula, square root p-hat 1 minus p-hat over n. So I do a square root of 0.69, 1 minus 0.69, divided by 1,034. I plug that in my calculator. I'm getting about 0.01, but the 2SD method says now take 2 times that. So I take 2 times that 0.01, I get 0.02. That is my estimate of the margin of error. It's the margin of error we're going to use here. So that equals 0.02. So I'm going to add 0.02 to 0.69, and I'm going to subtract 0.02 to the 0.69. So the upper end of the confidence interval is 0.71, and the lower end is 0.67. Again, you use the formula to find the estimate of the standard error, you multiply it by 2, and that's your estimate of your margin of error. This is giving you a 95% confidence interval estimate. So my estimate is that pi is between 0.67 and 0.71.